Welcome everyone to our Sustainability Stories event. We're so excited to be continuing these events throughout the year. We started doing them during Earth Day and had a lot of people tuning in, so we decided to continue as a way to share interesting sustainability and diversity, equity, and inclusion facets of campus. So we're really excited today to have Audryana Nay with us. She's a master's student in the School of Environmental and Forest Resources and the Astrobiology Master's Certificate Program. So she has developed a really awesome program. She founded a company called Nostos AI, which seeks to create a design tool for urban planners to incorporate meaningful and rich interactions with nature and sustainable city designs of the future. So first, I want to thank everyone for being with us today, and also Audryana, and now I will turn it over to her. Thanks, Audryana.
Thanks, Torin. Hi, everybody. Thank you, UW Sustainability, for having me here today. I really appreciate that opportunity. So as Torin said, I'm a master's student in CEFs here at UW, and my research kind of has to do with using artificial intelligence to incorporate more meaningful human-nature interaction into our cities. And out of that, I founded this company, Nostos AI. So I'll be kind of talking about that research and that company today. All right. So a little bit about the lab that I'm in. It's called the Human Interaction with Nature and Technological Systems Lab, the HINTS Lab for short. And what we try to do is, from a psychological approach, look into two world trends that are really reshaping our society today very quickly. The first is the degradation of the natural world, which we're seeing extremely fast within generations, and the unprecedented technological advancement and pervasiveness that we're seeing too. So both of these are really, there's an interesting intersection between these two things, and they're both culminating to a large movement away from nature and a decrease in interest in nature, and maybe even a loss of that knowledge of nature or how to interact with nature. So to kind of talk about some of the nature benefits that we see in different studies, nature interaction can decrease stress, aggression, rumination, crime rates in cities, ADHD symptoms, and then of course depression and anxiety. It can also increase eyesight. This is one that I think is really interesting. We've seen an increase in myopia in children, and that is kind of due to people having their screens kind of 12 to 18 inches away from their face most of the time. Whereas when you're out in nature, you're often looking at these large, vast vistas that your eyes are really focusing on things that are far away. And so we've kind of seen this trend of people losing that ability to see things far away as they've been more and more focused on their screens in front of them. So spending more time in nature can actually increase your eyesight and decrease cases of myopia. It can also increase social connectedness, overall mental health, and life satisfaction. And these studies aren't just self-reported. We've actually been able to see the effects of nature interaction via MRI scans. So this is a study done by Greg Bratman here at UW in 2015, and he was able to show a decrease in activity in the subgenual prefrontal cortex after nature exposure, which is associated with rumination. So we've been able to see via brain scans that exposure to nature can decrease those negative, repetitive thoughts that you often ruminate about, and that decrease your overall mental health. So that's pretty cool. So a big thing that we're trying to fight back against as a lab is what we call environmental generational amnesia. And this term was coined by Peter Kahn, my advisor and the director of the HINTS Lab. And it basically is the idea that each generation creates a baseline of the nature around them. So they create this idea of what normal or baseline nature is based on what they grow up with. So as they grow older, they of course see that nature degrades. But the degree of degradation isn't seen as extreme as it really is because their baseline is already a degraded state. So over generations, this culminates and people understanding the degradation of the natural world that we're seeing, but not having a sense of the true intensity of it. So to try to combat this, the HINS Lab is trying to revive what we call a nature language. And for as long as we've been a species, we've had this nature language and this way of talking about nature and the experiences that we have in nature. But as we're becoming more disconnected from nature, we are really losing that. And so when people, that results in people trying to talk about their experiences in nature and it not being super specific and it being kind of just, it was really fun or it was really cool or really refreshing. So what we're trying to do is revive this nature language by introducing the idea of interaction patterns. And an interaction pattern is basically a way of characterizing an interaction that we've had with nature. And that interaction can take many different forms, but it's essentially the same interaction repeated, and that's where the idea of the pattern comes in. So to come to an interaction pattern, you can first think about an interaction in nature that you've had that was very meaningful. So for example, you could think of spending the day walking around the lake with your friend. So then you'll characterize it in such a way that you can imagine many different examples of this interaction pattern happening, or this interaction happening. And even though all of the different instantiations would be different, say different places with different people, it would essentially be the same form of interaction. So if we're taking that example of walking around the lake, we could put it into a verb, preposition, and nature noun form and get walking along water. So here we have that same example, walking along the edge of water and land. So we can see that interaction happening across a diverse range of landscapes. So that could be around a lake, as I had said previously, across or along a man-made river, along the beach, or even along a fountain in a more urban area. So although these are very different landscapes, the interaction is essentially the same. So we've done previous interaction pattern studies on both nature preschools as well as looking at visitors' interactions to when they were at Discovery Park. So the Fiddleheads Nature Preschool is a really cool study that was led by Elizabeth Lev and Peter Kahn. And basically, this is led by Theo Weiss and Peter Kahn. And what they did was film children's interactions with nature at this nature preschool, where they spend basically all day outside. And so they were able to observe really crucial interaction patterns to these children that are really important developmentally. So a really great example is learning how to fall. So as kids spend time outside when they're developing, they learn how to fall, how to catch themselves, or how to not fall in the first place. So you can imagine maybe a group or a generation that grew up not learning how to fall. And then when they're presented later on in their life the opportunity to, say, go on a hike or something on a trail, they could say, oh no, I don't do that, because they're not comfortable walking on uneven terrain. So that's just one example of kind of the shifting baseline that we can see, where people are losing nature when they're young, and then that greatly impacts the nature exposure they can have for their entire life. Another study we did on interaction patterns was at Discovery Park here in Seattle. And Elizabeth Lev and Peter Kahn collected qualitative data from people who had visited the park. So people wrote in after they visited Discovery Park and wrote about what their most meaningful interactions were in the park. And so they were able to code all that qualitative data, and they were able to actually show that people's most meaningful interactions with nature depended on the relative wildness of the area. So that's huge, because Discovery Park is always under threat of being developed either into a music center or affordable housing, which are all great options, but I think it's important to acknowledge what you're losing when you develop that area. So we've shown with this study that you'd be losing all of these really, really meaningful interactions that people have and that are really important to people, which depend on the collective wildness of the entire area. So if you take out one component of the park, most of these interactions wouldn't be able to happen anymore. And that could be looking out from the bluffs onto the water, looking out over the vast fields, things like that. So while these studies are really cool and are very fruitful, they require a lot of time and manpower to do these analyses. They take a lot of time to kind of sift over all of that data and code each of the interaction patterns. So about 1.5 years ago, we started wondering if we could do these studies using artificial intelligence. So I started doing a proof of concept with that, and I did that with an API called Clarify, which, if you're interested, is a convolutional neural network system, and it's able to use extractors like SIFT or extract discriminative features rather than using extractors like SIFT and LBP. So basically what I did was I trained a proof of concept model that can predict 7 different interaction patterns. And we just started with 7 out of the hundreds that we have characterized just for this proof of concept, to try to kind of go for the low-hanging fruit first of all, and then choose interaction patterns that are either really important or that we think the system could easily recognize. And we got a accuracy score here of 0.85, which is considered good. So what this model can do is take images as input. So say an image of like a beach. It can run it through the model and then predict what interaction patterns can take place there without actually viewing the people doing the activity. So I'm going to exit out of screen sharing and just really quickly show you our proof of concept demo. Cool. So this is just the user interface front-end page for the API Clarify that I used for the proof of concept. And as I said, we started with 7 interaction patterns, which you can see here on the left-hand bar there. So those 7 interaction patterns are following the established path, lying on earth, viewing vista from vantage point, viewing a flat open vista, walking along the edge of water and land, walking along the edge of a forest, and walking the edge of a cliff. So basically we had over 1,300 training images in this data set, and I went through and tagged all the positives and negatives for these 7 interaction patterns. So if an example had a trail in it that you could walk on, I would tag that as a positive example of walking along or following the established path. If it had a shadow that kind of looked like a trail but obviously wasn't, I would tag that as a negative for following the established path. So if we look at, say, this example, so we can see that this was a positive training image for 3 of the interaction patterns. So this was a positive example for walking the edge of cliff, viewing vista from vantage point, and following the established path. And we can clearly see the affordances of the image that allow for that to happen. So an affordance is basically the natural feature that allows for the interaction to take place. So the affordance for following the established path is the path here. So then if we look at a picture that I haven't trained with yet, so this one here. So I haven't used this in the training set. I just uploaded this into the model and we can see what the model predicts. It's kind of small here, so I apologize for that, but it's a beach scene kind of with an urban background back there. And it comes back with a prediction of 0.97 for walking along the edge of water and land, which is because there's this body of water here along the beach. Lying on earth, which is because sand is often conducive for lying on the beach and things like that. And then we also have viewing a flat open vista as pretty high here, and that is because the water allows for that big open view to be there. So I'll go ahead and stop sharing that. So from this proof of concept, we can see that we have a working model for 7 interaction patterns and that it is plausible and scalable. So we can take this model and theoretically scale it up to include a lot more different interaction patterns. So from that research, we quickly saw the commercial possibility of this. So we formed the company Nostos AI. And the idea of this is that we can use a tool like that to analyze an urban setting, identify the interaction patterns that can take place, and then provide design suggestions for the planner to incorporate more meaningful interaction with nature in our cities. So Nostos AI is a design tool for urban planners who want to incorporate more nature into their designs in maybe a way that's not so intuitive. So just to give you kind of an idea of how this product will work. First, the planner identifies the design area. So they can do that with GIS, which is kind of like a mapping analysis system and is tied to location. We can then pull in the data and run our interaction pattern analysis. And the data in this case will be Google Earth, Google Map, and Google Street View data. So we're still working with images. We're just getting those images from a public source. Nostos can then provide design suggestions for the area and assign a nature interaction score, which I'll talk a little bit more about later. So the user can then take those suggestions and design in like a CAD software such as AutoCAD or Rhino using those design suggestions. The designer can then upload those renderings of their design to our system, and we can analyze it again for interaction patterns. And then we can suggest any kind of tweaks or changes that could be made to get a more rich nature interaction in the area. And again, we can assign a new score here. And from there, the user can then modify their design once more. So it's kind of like an iterative process that will take place throughout the entire design process for the planner. So we have a user interface demo here that I will just show, and I think it'll make a lot more sense after we show that. So in this example here for our user interface, we just have the Googleplex campus in California. And so the urban planner can identify that using a GIS layer, and then we will pull in the Google data for that. Then we'll run our analysis on it, and we can then pinpoint all of the opportunities for interaction patterns in the landscape. And so, for example, we can click on one and see all of the interactions that are taking there, as well as the affordances that we would recommend the designer preserve. So in this case, that is the tree, the grass, and the path. So they can be very simple, like you see here, but when you combine a lot of them, they can get very complex. You can actually get a really cool nature interaction story. So then we can also look at it in terms of interactions. And then we can take a look at all of the interaction patterns that can take place in this subsection here. So here we have 20 different interaction, or 20 total interaction patterns that can take place. So we would call that our interaction pattern richness. So interaction pattern richness, we're borrowing from the ecological terms of species richness. And that is just the total number of interaction patterns that can take place. Then we have 6 unique interaction patterns that can take place here. And that is the interaction pattern diversity, again, borrowing from species diversity. So those are kind of the foundations of our scoring system that I will talk about. All right, so as I've mentioned, during certain parts of this process, we will provide a nature interaction score. And that'll take place after we've done our interaction pattern analysis and looked at the baseline area, as well as after we've analyzed the design renderings that urban planners put into our system. So this nature interaction score tentatively is based on 3 things. The first is that interaction pattern richness and diversity that I mentioned to you in the user interface demo. So that is kind of the foundation of our scoring system. Then we have our HintsLab Intuitive Nature Index, which is a process of going through different images in different urban areas and intuitively saying one is more nature rich than the other. And from doing this process, we can eventually train an AI system to recognize what we as a lab would assign the images to. And this is based off of a process by Christopher Alexander, who created this idea of patterns in design for architecture. So one of his patterns is windows on 2 sides of a room. And it might seem obvious, but once you implement that, you can see it implemented in lots of different instantiations of design. And he did a similar process with his lab of just going through and trying to nail down what patterns are important and what works intuitively. So we're kind of modeling our intuitive nature index after that. And I guess I should mention that Alexander is also kind of the creator of the idea of patterns, which we see in a lot of different areas now, from obviously eco-psychology that I'm talking about here to computer science and many others. The third part of this nature interaction score is going to be certain biophilic design principles that we're weeding through as a lab. And we're drawing these from Kaplan, and Ryan's biophilic design principles, as well as Kellert's design principles. And the idea of biophilia is basically that we are innately drawn to nature as a species since we came of age with nature. And so by incorporating nature into design, you can have a more aesthetically pleasing or welcoming design. And so we are going through those biophilic design principles that are out there and choosing which ones we think are important for an urban planning context and which ones we can maybe get rid of. So the last thing that I want to talk about is what our cities will look like post-COVID-19. So this project, when we started out, maybe about a year ago with the company, we were looking at a very different world, and we were looking at one that was going to be more and more urbanized for the sake of sustainability, really trying to minimize urban sprawl, things like that. And so the idea was we were trying to incorporate more meaningful nature interactions into our everyday urban lives so that people wouldn't have to go out of their way to go into rich nature. With COVID-19, we're seeing a concern of dense populations and things like that. And there's kind of been a trend recently of a lot of people moving out of these large cities. And so these actions that are taking place right now could have really long-term effects. So we could start seeing smaller pocket cities popping up, maybe in what is now suburbs or rural areas. And so we're trying to kind of figure out what will that look like post-COVID-19 and how will Nostos AI fit into that. So one scenario, as I said, is smaller pocket cities outside of larger cities. People might continue to work from home for the foreseeable future, and there might be limited public transportation for the sake of limiting contact with other people. So maybe instead of looking at large cities and trying to include nature into those cities, maybe we're looking at a future where we're redesigning cities completely from the ground up in more rural or suburban areas. So how can Nostos AI, retain as much nature as possible in these new cities, new pocket cities? And furthermore, how can we design living areas that are conducive for working from home? So as you've all probably experienced, one of the major problems from working from home is that there's no separation between work life and home life. So how can we design for residences that are conducive for working where you live? And then since there might be limited public transportation, how can we make these small pocket cities completely walkable and accessible for all people? So that's kind of the future that we're thinking about. And so we're trying to situate Nostos AI in a way that it could work on these big, large, dense megacities, but it could also be really impactful for these smaller pocket cities that might pop up. One big factor that I'm trying to work out right now is how do we prevent green gentrification, which is the idea that as more nature is included in areas where people are living, it drives cost of living up and property values up and drives out often minority communities. So how can we address that? That's one big concern that I have that I've been grappling with. So let's see here. So that's all the slides that I have for you guys. My contact info is down here in the lower left. I would love any emails with any questions that we might not get to today. And I guess the final thing I'll say is that Nostos AI, while it is about thriving nature, it's also about thriving people. That's kind of like our company motto is thriving people, thriving nature. So by improving the nature, we can also improve people's lives in really meaningful ways. And so I'm really looking forward to kind of being a part of that. So thank you guys, and I would love any questions that you have. I see there's questions on the chat here. So I think what Torin said is that we'll be answering questions in the chat, and then I can go through those. So if you want to drop those there, that would be great. Thank you guys. Let's see. Sarah said, asked if there will be a recording. Yes, there will be a recording, I think on UW Sustainability's YouTube page. Yeah, Pattern Language, great book, yes. Marilyn said, what are your thoughts about how well the campus aligns with the ideas that you've described? That's an interesting one. Overall, we're really fortunate at UW to have a lot of nature contacts on campus already. One area that is really interesting for me is the quad. And you have all these different paths that are connecting different buildings. And from what I get, the idea of those paths was that they were kind of designed to follow paths that they think people might want to take intuitively to get to different buildings. But what I find when I walk through the quad is that often where I want to go is not where the path is going. And so I've been thinking a lot about that. And it has to do with one of the interaction patterns that our lab has described, which is finding the line in nature. So often when you're walking through a landscape, there's kind of a line in the landscape that you intuitively want to follow. And that might just be because of the contours of the earth, objects in your way, things like that. And so when I'm walking through the quad, the paths aren't really where I think the line in the landscape is. And so I think that that's one thing that could be incorporated into design, especially say corporate campuses or university campuses, so that people, when they're walking along these paths, they feel connected to the earth via this interaction pattern that we've been enacting for hundreds of thousands of years. So that's just kind of one idea that we could add to the university campus idea. But overall, I think that there's a lot of biophilic design in our corporate campus or in our university campus. So one aspect of biophilic design that's really interesting at UW is by Drumheller Fountain, there's all those roses that are beautiful, but they're kind of fenced off by those hedges. And according to biophilic design, that is a great design. You're bringing nature into an area where people are often traversing. But you can't really interact with those flowers in any way other than looking at them, because they purposely block you from going anywhere near them. So according to interaction pattern design, which is what we're trying to push with Nostos AI, that's not a great design. And ideally, you would want to incorporate some way for people to interact with those roses. So paths through that area, things like that would really increase the interaction that's possible with those roses. Cheryl said, can you say more about the weight/value given to food production as a factor in the planning model? Yeah, so that's a really interesting one. In our kind of predicted future for pocket cities, ideally food, or each of the cities would be self-sustaining, including food. But that's kind of far-fetched. So as far as food production, right now there's kind of this model of, it's called systems theory, of everything being done the same way across the globe in order to be done the most sustainable way. So food transportation is a great example. Things are grown in areas that are conducive to that food, and then it is transported everywhere around the globe, basically. And that's how almost all of our food is produced. So according to systems theory, that is the most sustainable way to do that. But what I don't think the systems theory takes into account is differences in just environmental conditions of different areas. So what's sustainable in one area might not be sustainable in another. So for example, we could take like an airport model. Airports are designed the same way pretty much all over the world. And that is, according to systems theory, the most sustainable way to do that. But what if, you know, in like American Southwest, things were built with like adobe or something that was more sustainable to that specific area? According to systems theory, that's not sustainable, but according to the local conditions of the area, that is the most sustainable option. So same with like the food delivery system. I think we really need to look at it not so much holistically, but at different individual areas and figure out like what is conducive to that area. So in our pocket cities, we're not going to be growing the same thing all over the US. You know, it's going to be different, and it has to be sustainable to that area. So that's just one aspect of food production that I've been thinking about. Sophia said that she volunteered at Fiddleheads. I remember seeing individuals film with student interactions with nature. Was that video some of what was used to train the AI system? Probably. Well, not the AI system, but that was probably for our labs paper, which was then informing our AI system. So that's pretty cool. I'm curious to hear what brought you to this work and how it has changed your interaction with nature. Yeah, that's really interesting. So let's see. I joined the lab almost 2 years ago, I guess now. And what brought me to that project specifically was that the lab before I had gotten there was trying to figure out how to make these studies more efficient. Because our lab, we kind of move at a slow pace with our studies. We're not exactly the quickest lab out there. So they had that idea, and they were trying to make it specific to more smaller domains. So they were thinking maybe we have a model for nature preschools, and maybe we have a model for urban parks, something like that. But I was kind of more interested in the dense megacities of the future and what we would have to do to live sustainably on this planet with our increasing population size. So I proposed a model that would work in different landscapes and different types of urban densities across the globe, and be able to say something about cities no matter where they are. And so kind of taking that idea and making it much more scaled, much bigger, basically. And so that's kind of my interest in this project and how I got started with this. And then how has this changed your interaction with nature? I would say it really has changed my interaction with nature. I think in our everyday lives, we tend to just forget to like smell the air or just look up at the sky or just admire the trees, because we're constantly moving and we're constantly busy. And through this work, I've really learned to appreciate those moments and recognize them. Also, now when I look at pictures of nature, I immediately identify interaction patterns. So that's just something that has come with that work as well. And speaking of that, with the COVID-19 quarantine, I think that globally people are recognizing and really realizing the powerfulness of nature and how important it really is to their lives. Because as people are stuck inside now, people I think are really craving that outdoor nature interaction. And so hopefully if anything good comes out of this quarantine, it's that maybe there will be a revitalized sense of how important nature is to our everyday lives. Has your research involved talking with landscape architects who work at the intersection of human needs and ecological health? The designs on campus that you critique are also historic landscapes that have significant cultural value. Would you propose limiting those historic landscapes because they don't work for your model? So yeah, I have been working with landscape architects, both because I need their input to inform my research and our product, and also because they will be the likely users of our product. And so I have been talking to them, and I found through some survey data that 96% of urban planners, which we have grouped in there, architects and landscape architects, 96% of them try to currently incorporate some sort of nature interaction into their designs. But those 96% say that there is no design tool to help them do so. And furthermore, they face a lot of roadblocks from financial decision makers or people who have an overall say in the design who don't want to include nature interaction or see it as a waste. So hopefully, Nostos AI can be a tool to quantify the benefits of nature interaction or quantify the amount of nature that is in an area and show people that it really is worth including and that it's really important and will make a difference in people's designs. Yeah, the other thing that we've also gained from those talking to landscape architects is that they want to be the ones who do the design. So they don't want our tool to do the designing for them. So that is why we are only giving design suggestions and not, completing the design or giving them mock-ups or anything. So the designs on campus they critique are also historic landscapes that have significant cultural value. Yeah, so one thing that we've been thinking about with this system is, should we try or strive to achieve historic landscapes or what the nature in the area was in the past? And we've kind of concluded that's probably not, mostly because what was natural to the landscape back in the day may not be sustainable there anymore due to climate change, shifting populations of species, things like that. It just might not be attainable. As far as the cultural value of those landscapes that are there, yeah, I definitely think that, as I said, the ultimate designing is down to the urban planner or the landscape architect or the architect. So we wouldn't, be saying, well, you should get rid of this. Through our nature interaction scoring system, those like roses near Drumheller Fountain, for example, that area would definitely get still a higher score than if it was just hardscape in that area. So definitely the landscape that it is right now is better than, say, hardscape or something like that. Yeah, if you have any more questions, I would love to take those. You can also email me questions. My email is audryn@uw.edu. I'll put that in the chat. When do you plan to go live with the product? As soon as we get the funding to engineer it. So planners can buy and use. Yeah, so we have the user interface, we have the guts of it. Right now it's down to just getting the funding to engineer the product. And we're not sure if we will use, outsource that engineering to a different country. We're not sure yet. So yeah, it's all kind of depending on the funding right now.
Hey, this is Damon with UW Sustainability. I was just going to say, if anybody else has any questions, feel free to put them in the chat. We've got a little bit more time. Also, just wanted to say to everyone, thank you for joining us. I just had one question, which is, what is the, what do you see as the biggest difference, or I guess, what are the current tools, and what is the biggest sort of difference or gap that you see filling it, because I know there's a lot of kind of, different ways that planners look at, incorporating nature or looking at nature. And I was just kind of curious what you think about, if there are current tools, or what are the, some of the current methods that are out there.
Yeah, so the most widely used, I guess, tool is this idea of biophilic design. And this is kind of driven by many cities mandating that there's a certain amount of green space or a certain tree count per area or something like that. And through these techniques, you often get areas that are large open grass with maybe a few trees that are greatly underutilized. So, in front of like an office building, for example, you often see maybe like a green lawn with one or two trees, and that's it, and no one uses it other than for visual interaction. So what we're trying to do is maintain that same level of greenness, I guess you could say, but make it more interactive and something that people will actually use and get benefits from. So rather than having just that open green space that would come from biophilic design or city mandates for green space, you could have more treed-in areas with vegetation, trails, things like that, water features that get your like auditory attention, areas that are more interactive, basically. So that's kind of the overall goal and the difference of what makes Nostos AI stand apart from other tools.
Thank you. It looks like we haven't seen any other questions in the chat, so it looks like that might be a good place to stop. I did, we'd mentioned this in the chat. I didn't want to let everyone know that this is being recorded. We will post it, probably within a few days or next week on our YouTube channel, as well as on the UW Sustainability website. And we are going to continue to have more of these events, these sustainability stories events, talking to different people across campus and the work they're doing around sustainability. So you can always follow our website, green.uw.edu, or our Facebook, Twitter, Instagram. We'll post all those on there. And just really want to thank Audryana for her time here today and the great presentation. Thank you.
Yeah, thank you guys for having me. I really appreciate it, and I really enjoyed it.
Yep. Thanks to everyone for being here.